Hi, this is your host Swapnil Bhartiya and welcome to your Let's Talk. And today we have with us once again Billy Thompson, Cloud Engineer Manager at Akamai. Really good to have you on the show.
As always, thank you for having me. I appreciate the opportunity.
It's my pleasure to host you. Of course, I have talked to you so many times, but we are all getting ready for KubeCon, Collaborative Con. So I would love to, kind of focus on this interview from that lens. And I would also like to kind of tell our audience a bit about you and Akamai. So talk a bit about yourself and Akamai.
So I am a customer-facing cloud engineering manager for Akamai, and I serve a few different functions. I currently overlook the team that does all the development work and all the automation for the one-click apps and clusters in our marketplace. And I also serve as a resource on the evangelist team to communicate with the industry, to interface with the voices out there, the engineering leads, the CTOs, the analysts, the whole bunch, and to talk about cloud native, portability, and good strategies for future-proofing your success in this environment versus all the issues and pain points that people commonly run up against in cloud computing, such as the egregious costs, the cloud waste, the vendor locking, and just other general pain points. And on top of that, I'm just overall a huge proponent for open source and for community. And here in Philadelphia, I'm a co-organizer of the Philly DevOps meetup.
Now, when we look at, this whole ecosystem, we have seen so many trends, so many patterns. We talk about so many personas. One of the personas, or one of the emerging, it's not emerging anymore, is platform engineering. Talk a bit about what is platform engineering, how is it different from other practices, what is its main goal and objective.
I'm really glad that you asked that. And I'm really glad that you mentioned that it's not as trending anymore, because I think that's a very good thing, because I feel that a lot of the reason it was trending before had a little more to do with some marketing buzz than it did with practicality. And we've seen that with AI and even things such as Kubernetes. So at this state where that bubble has kind of popped is, I think, where we typically see the best use of a new emerging practice such as platform engineering. So what is it exactly and how is it different? To understand that, let's take a look at the parental figure here, the alpha and omega, which would be DevOps. And the problem that it ultimately looks to solve comes down to a culture problem. I love the memes of the something's on fire, and you have the dev side and the ops side, and one is saying, well, it works fine in my environment. That's your problem. So where DevOps seek to resolve that cultural issue, being like, okay, how can we build in this middle layer here and some automation to reduce the toil on both sides, and then thereby development teams can operate very independently, very rapidly. Life looks better if the culture is right to support that methodology. Now that is really good, and that's awesome that these teams can work independently like that, in that loosely coupled style, similar to the joy that we get on our faces when we consider that for things like a microservices architecture. But at a certain point of scale, that starts to bite. It's great that we can have these development teams so independent and iterating at their own pace. But at a certain point of scale, when you want to do, this is just an example, a sweeping but seemingly simple task like Debian 10 is EOLing and Debian 12 has been stable for some time now, let's upgrade the whole fleet. And then you suddenly realize that that is not so easy to do. In fact, that can be quite a mess of a project to do. Because here you have these diverse teams, and sometimes geographically diverse, that are so independent, and all the various DevOps tooling and everything that has developed processes for that team to streamline what they do, which is different than what was built for this team to streamline what they do. And it becomes extremely difficult to scale then when you have different stacks, different tool chains, and even different processes and ways of using them spread out all over the place. And now here we're end of the year planning and talking about the next great initiative for Q1 or Q2. And but we can't do it because it's really difficult to make this change actually spread out and have some fluidity to it. So this is where platform engineering specifically comes into play, because platform engineering is then going to be the practice that looks at all of this and says, how can we standardize these different development platforms? How can we standardize these different development environments that these different teams are using? How can we make it self-service? And how can we make it so that we are reducing the toil overall for the entire organization with our dependencies, our tool chains, and so on? Because as you can imagine, with all these various teams in their independence, doing what works best for them specifically, there's this massive proliferation of the amount of tooling that needs to be maintained, that needs to be learned, that needs to be kept track of, that needs to be observed, and that needs to be secured. And this can get overwhelmingly complex. So a platform team would be deployed to take on that task, to have communication with all these other teams, and to create that standardization layer so that they have the same sets of toolings and things that they need to work on to do what they do well. But all of this can only happen, once again, if the culture is there to support it. Because platform engineering has emerged as this new best practice, as everyone likes to call it. And I really struggle with that term because while I agree with the logic behind calling it a best practice, if you assemble, let's say, a platform team for the sake of this is the best practice, this is what we need to do, it will save us all these costs and so on, but your individual teams don't adopt the platform, there isn't good communication across the silos, and the implementation of it essentially just turns into rebranding DevOps into a platform engineering team, you haven't solved the problem, regardless of it being a so-called best practice. But that level of scale, and when you get to that point where you have these unique teams that can work on different things and they need to operate at their different speed, and you need a way to bring this all together, that is platform engineering.
And as we are talking about, these teams and the cultural changes, can you also talk a bit about that when new technologies, I mean, Kubernetes is not new anymore, but when we look at some of these technologies, they kind of also, sometimes those cultural changes are needed because of some of these technologies. And sometimes these technologies become a catalyst to bring that cultural change. So can you also talk about what role or what kind of role is Kubernetes playing in platform engineering?
So aside from just being a really awesome orchestration engine, yes, building applications for Kubernetes does help to foster exactly that type of culture change. When you need to either write new code or decompose existing code in a way that you can break it down into smaller services where you have one or at least very, very few, far less build artifacts, and how you're looking at one, how can these be loosely coupled, but how do they also need to communicate with each other? That design philosophy, that strategy, and that ability to not get locked into any one thing and to be modular like that is exactly the type of mindset that you should approach organizationally a strategy like platform engineering. It just fosters exactly that. And in addition, Kubernetes is a great example, just the technology on its own is a great example of how powerful it can be. Something that is based on open standards, that is based on interoperability and that flexibility where anyone can work with it the same way, tap into it the same way, they can add on to it, they can pull back away from it, and can run it on any cloud provider and even in any on-prem environment, provided the networking and storage and compute resources are configured in a way to do it, but that it can run anywhere and everywhere, and that even all the different cloud providers with their various sets of tooling are just making extensions to work with this one thing that everyone can use exactly the same. And the ecosystem of CNCF projects, the 15,000 or however many people come to KubeCon several times a year, the massive enterprise adoption, this huge expansive industry and the amount of scale that's possible from it. That is powerful. That model is powerful. Now let's apply that culturally. Can you imagine an organization with, say, 1,000 engineers trying to push products faster than everyone around them? To have that much flexibility, to have that interoperability and that fluidity through how they work together because they have the continuous reconciliation built into their culture. They have the continuous feedback that was promised by DevOps, but also the independence that brings it all together into one system that works smoothly. That is powerful. And some other technologies that I think really highlight the art of the possible here, and this is actually something that this is the trend that I would like to see, and that is that cloud providers take a bigger stand in packaging what platform engineering really needs, right? So Kubernetes, of course, tooling of choice for many, but I'm also a huge fan of projects like Backstage or Otomy, right, that bring together these internal developer platforms, which are at the core of essentially what you're doing with platform engineering. But I would like to see a trend where cloud providers do the heavy lifting of packaging these together in a way. Right? They've done all the plumbing behind the scenes, make sure everything works, so the end user experience, the developer experience, easy to get these up and running, to make them deployable, to make them templates, and make them be able to expand on them from there and to run them on any cloud provider. And it should be a stack of open source, vendor agnostic tooling. And that's a little bit of a controversial thing to say specifically in the context of platform engineering. I can hear the wonderful people on Reddit screaming about having more things to manage and this argument for once you're at that level of scale, please, by all means, reduce the amount of what you have to take care of and bringing in more third-party services that other people manage, being your best friend. But then that also gives you that major disadvantage that is pretty agreed upon within platform engineering of you getting stuck to certain sets of tooling and being at the whims of deprecation or upgrades that are maybe a little shy of backwards compatibility and so on, and things that then put you in a position where you now have to reinvent the wheel again, and now you're not reaping the benefits of platform engineering. So if we take these open source stacks, but they're packaged in a way that just comes native to each provider, but there's nothing about them that you can't run it here, there, and most of that complexity has been stripped away before it got to you. that is a powerful trend that I would like to see happen.
Excellent. Once again, thank you for a great insight there. Now, if you did touch upon that in your answer, but I also want to talk about that it's not rosy all the time. At the same time, everything is not gloomy and bad. Same thing is with platform engineering. Can you also talk about the benefits when team embraces the platform engineering approach, and what are some of the drawbacks? Now, what offsets what? How to overcome those drawbacks in the lieu of the benefits that it brings to the teams?
So the benefits, I think, as I mentioned, just that fluidity of people being able to actually have the communication that is required to ship software quickly. So we're talking about faster time to market. We're talking about happier SREs, because when it comes to platform engineering, right, your customers are internal. Your customers are going to be the product teams and the SRE teams. So the benefit being here is that you took the rapid iteration, the ability to experiment quickly, the ability to be independent and have that continuous feedback loop, but you brought it together at scale so you can massively release products, way more scalability, increased operational efficiency, and a better culture, and an overall better operational strategy when it comes to cost. Because of how easy it is to deploy cloud resources, it becomes very easy to over-provision and have underutilization, especially when this starts getting distributed across various teams that each need to deploy something, which will include some infrastructure, some config management, and so on to create their environment to develop the products that they need to do. A good platforming engineering strategy is one in which the amount of actual custom code and glue that you have to provide for each of these teams is very, very minimal. And that on its own, it's less toil for you as an organization. It's less toil for the devs and ops side of this that need to learn different things. They can just focus on their skill sets. And it helps in that the question of ownership becomes very, very clear. When you have an internal developer platform that is totally self-service, the person who provisioned it, the team who provisioned it, that's who owns it, and that's who should own it. That's who should be waking up at 2 a.m. to a PagerDuty alert if something is going wrong. It shouldn't be the platform team. It shouldn't even necessarily be the DevOps team, right? So who are the owners, right? Are those the product teams? Is that the SRE teams? This provides a clear path of who owns what. And doing so reduces that burden on both sides. It's a better developer experience, and it provides a huge reduction in technical debt. Because when you start standardizing all these tools and you're really looking to reduce the proliferation of them, you're reducing the amount of technical debt that you have to overcome to continue to succeed. Now, to comment on some of the disadvantages, I would honestly sum up most of them to the same issues that people run into when pursuing, say, a multi-cloud strategy, such as the complexity or technical overhead of that, the cost management aspect, or securing data across these different environments. And the more of these you have spread out and the more drifted they have from each other, that becomes a serious problem. But those disadvantages are still something that I believe is initially solved with a culture change. Being able to embrace simplicity in your architecture, not over-architecting, not making it more complicated than it needs to be for you at this stage in your journey so that you are making it maintainable for yourself. You would do that when you're exploring a multi-cloud strategy. You would do that when implementing a platform engineering team, right? Keeping it simple, reducing the complexity, that's reducing the cost. The standardization aspect. When you have a very standard way of how you're going to configure an entire stack, an entire environment, and it looks exactly the same, right? What people do with it inside of that, that's their shell, write their code, do it up. But in terms of the provisioning of it, the parameters around it, if that looks exactly the same, whether it's on Akamai, whether it's on AWS, whether it's a blue-green deployment and you're testing out some things with Edge Native and other things, doesn't matter. If that looks exactly the same, that is way easier to secure data in a consistent manner across these different environments. That is way easier to observe, that is easier to plan for, that is easier to heal from when something didn't go right. It is easier to document and make sure that everyone makes sense of it and to make sure that everyone is on the understanding of what is what.
What would be your advice to an organization evaluating, shifting to platform engineering approach, whether it's right for them, whether it's not right for them, and if they do plan to move forward, what kind of practices they should build internally?
So I would say first and foremost, do the evaluation of if you need a platform engineering team. Because a smaller company, startup phase, maybe 10 engineers, you probably don't need one just yet. But I have seen a lot where things like this are implemented early on for the sake of future-proofing for this scale that you wish to reach at some point in time. And I think it's important to keep that front of mind. But the better future-proofing strategy here is not to implement a methodology or even a piece of technology like Kubernetes before you actually need it. It's just overhead at that point to make it more difficult for you to budge forward, and it overcomplicates things. That builds technical debt. That works against you. So making the evaluation of, do I have an architecture and a culture that when we get to that point in scale, we can benefit from having a platform team? That's really important to do starting out. If you are a larger company and you are suffering from the issues of scale and you have different things going on in different places, this is a great time to consider bringing in a platform team. But again, the culture is really, really, really one of the biggest parts of this, because the technologies will help to lay the foundation for what the culture needs to be, but you got to adopt it. So have that evaluation, be open-minded about it, think about future-proofing by design. The next bit of advice I would give is don't rebrand DevOps as platform engineering. These are different things. They behave differently at scale. If you just simply take some of your DevOps engineers and rebrand them as a platform team, and they are still writing custom tool change and automation pipelines for these various diverse teams working on different things, you haven't solved the problem. You haven't gained any of the benefits from platform engineering. You're just further contributing to a proliferation of tooling and resources to manage and to pay for. So very important to understand the differences here between what is platform engineering and what is DevOps, and do not just rebrand it to platform engineering because that's what the hype is at the moment. And the last thing that I think is very important is to check the platform engineering reference model. It is a very interesting case study and discussion that aims to make this terminology, the term platform engineering and the related terminology around it more ambiguous, so we all have the same understanding of what it is exactly, and also goes a lot deeper into, the problems that it intends to solve and the various benefits that can come from what it is and what it looks like, who should be involved, and gets a lot deeper into that than what I have time to go over today. An excellent resource. Should always look at that when considering implementing a platform engineering team.
Billy, thank you so much for taking time out today and, of course, talk about platform engineering. Thanks for those great insights. And as usual, I look forward to chatting with you again soon. Thank you.
Thank you again for having me.